This is the second part of our previous video. So here let form a superposition equation of equilibrium of forces. AD is equal to ADL plus S into D. We have all values. Let assemble here. Put the value for stiffness matrix ADL and AD, and also the D1, D2, D3. Those are our unknown theta B, theta C, and delta. So now after putting the value, we have these form. Now take this minus 14.58 toward the left hand side, it become plus 14.58. Now EI is keep outside, so first row into this column. So 2.33 theta B plus 0.67 theta C plus 0.375 delta, taken this EI outside. Now next is 9.86, which become plus positive toward when we take toward the left hand side, and the second row into this column, it become 0.67 theta B plus 2.67 theta C plus 0.67 delta, and the last row into this column, taken EI outside and take the 36.67 minus toward the left hand side, it become positive. So 36.67 is equal to EI in bracket 0.375 theta B plus 0.67 theta C plus 0.64 delta. So solving this simultaneous equation, we have theta B is equal to minus 1.39 EI, theta C is equal to minus 14.29 EI, and delta is equal to 73.08 EI. Now put these in the slope deflection equation and find out the end moment. Now first let's consider column AB and find out the end moment for at end A and B. This one is a formula for slope deflection equation. MAB is equal to MFAB plus 4 EI by L theta A plus 2 EI by L theta B plus minus 6 EI by L square into delta. Now this delta is there, and theta A will not be there because this end is A is a fixed end. So theta B will be there, rotation is there, and MFAB will be there. So by putting the value of MFAB, theta B, and delta, which is calculated earlier, we have 60.04 kilonewton meter moment at end A. Now find out for end B. The formula is MBA is equal to MFBA plus 2 EI by L theta A plus 4 EI by L theta B plus minus 6 EI by L square into delta. So here delta moment due to the delta is positive, so that's why we take a positive sign for 6 EI by L square delta. Now again the A is a fixed end, so the this theta A term will be 0. Putting the other value, MF PA is minus 33.33, theta B we know, delta we know, and we take a positive sign for this moment, assuming the moment in a toward the delta toward the right side, or moment in anti-clockwise direction as a positive. So by putting the value of theta B and delta, we have minus 7.315 kilonewton meter. Now let's calculate end moment for beam BC. End B, formula is MBC is equal to MFBC plus 4 EI by L theta B plus 2 EI by L theta C plus 6 EI by L square delta. Now here all term will be present because there are rotation at end B and C, and delta also for the now here delta term will not here because of we are talking about the beam BC. So we must note down this thing when we are doing a calculation for a beam. the delta term will be disappear because the only we are assuming the column are sway. There is a sway in the column, not for the beam axial deformation we neglecting. So the delta term will not be here for when we calculating the end moment for the beam. So find out theta b and theta c values which calculated earlier. Put here, put mf for bc. We have 7.37 kilonewton meter. Now find out end moment for the beam bc at c. So formula will be mcb is equal to mfcb plus 2 ei by l theta b plus 4 ei by l theta c plus 6 ei by l square delta. Now again the delta term will not be here because we are doing a calculation for beam. So for beam we neglect this way, so don't consider delta for beam. Put the value of theta b, theta c and mf cb. We have putting the value, we have the end moment at c. mcb is equal to minus 38.726 kilonewton meter. Now the end moment for the column cd. Now when we talk of a column, when we talk about the column, the and there is a sway frame, so delta will be there, delta term will be there. Now this is a column, so delta term will be appeared now and it is a sway frame. Okay, so the formula for mcd is equal to mfcd plus 4 ei by l theta c plus 2 ei by l theta d plus 6 ei by l square delta. So putting the value of now here the d end is fixed, so theta d will be 0, other term remain as it is. Theta c will be there, rotation at c will be there, delta will be there because it is a sway frame, so column going to sway, and mfcd will be there. So putting value of mfcd 8.89 and the value of theta c and delta which is calculated earlier, we have 38.56 kilonewton meter moment at end C. Now find out for end MDC is equal to MF DC plus 2 EI by L theta C plus 2 4 EI by L theta D plus 6 EI by L square into delta. Now again theta D term will be 0 because the D end is a fixed end and the other term will be there. Put the value of MF DC as a minus 17.77, a value of theta c and delta as calculated earlier. We have MDC end moment is equal to 21.46 kilonewton meter. Now we have all end moment. Now draw the bending moment diagram for the given frame. So bending moment diagram for the, let's draw for the loading. First load is UDL, 25 kilonewton per meter UDL. So the formula is WL square by 8. W is 25 and length is 4 square divided by 8, it become 50 kilonewton meter and it is parabolic in fashion. For 50 kilonewton point load at midspan, the formula is WL by 4. W is 50, L is 3. So we have in triangular fashion, it become 37.5 kilonewton meter. And for next load 40 kilonewton on the column CD, it is WAB by L which is not at the center, so it become 26.67 kilonewton meter in a triangular fashion. Now the end moments. Now first end moment is 60.04 kilonewton meter which is positive, so rotate in a anti-clockwise direction, arrow coming toward the left side, so show toward the left of a column. Next moment is 7.37315 kilonewton meter which is negative, so rotate about B in a clockwise sense, arrow coming toward the left side, so show toward the left, and then you have to join. Now the next is your beam BC. The end moment at B is 7.1315 which is positive, so rotate about B in anti-clockwise sense and arrow coming off, so show off. And next is 38.726 which is minus, So rotate about C in a clockwise direction, arrow coming up. So both values are shown up. And next is value is 38.56, which is positive. So keep rotate about C in a anti-clockwise sense, positive value. So coming arrow coming toward the right, so show right. And the next is 21.46, which is also positive value. So rotate about D in a anti-clockwise sense. This is anti-clockwise sense, arrow coming toward the left hand side, so show toward the left. So by joining you will get triangular fashion. So this is about the bending moment, superimposed bending moment diagram. Okay, thank you.